Okay. Hey everyone, how's it going? Sorry I'm running a little bit late. I had a lot of traffic on the way here coming from Greensboro. So wanted to kind of get my act together first. So we're going to talk about chapter number 4, maximizing attribute tables taken from the book. I sent an announcement, we sent announcements a couple weeks ago about the crime mapping link from about 10 days ago last Friday. I did post a couple of jobs here. I want to talk about these briefly. Also, take a look at possible projects that we have. So we have a couple of projects that we have that we're gonna highlight here, but got some jobs here. This one's neat right here. This is from the North Carolina internship program I highlighted. It's coming up. We'll probably talk more about that later. But we've got jobs for the engineering technician 3. We've had a number of students take on these jobs. These are in the photogrammetry unit. And you can see down here, and it's already kind of a trick question here, but photogrammetry, you can see up at the top, acquires aerial imagery and generates geospatial information products used for transportation planning, design, and construction. It uses advanced technology, things like orthophotography. Orthophotography is just a big fancy word for airplanes flying, taking pictures with really fancy cameras and geo-registering it, basically giving it GIS coordinates so it could be superimposed on real world imagery. Kind of like the stuff that we did last week where we were tracing out buildings. It uses something called LiDAR, light detection and ranging, as opposed to radar, which is radio detection. So it's just different wavelengths. We have students that work here. We have 2 current students who work there. One of them just transitioned to utilities, and then we have another student who works in the surveying unit here. But practices LiDAR, GPS surveying, GIS related to highway location design and construction. I'm a big proponent of NCDOT because, first of all, they provide an HBCU fellowship program. A couple of weeks ago, I met a couple of students there that were part of this program. One of them actually wants to go to grad school here. I'm currently recruiting him. He went to A&T. We won't hold that against him, but he wants to come here for grad school and he works full time. But I thought this was kind of really, really neat stuff here. This is an engineering tech 3, so it expects years of experience. But my expectation is pretty soon there's probably going to be an engineering 1 or 2 tech coming open because their engineering tech 3 is probably going to be promoted from within, and then they're going to open up this engineering tech 1 or 2 position here. But you can see the pay, $43,000 to $76,000 a year. These people work for the state, so it's relatively easy to see, to see what they make and all that other good stuff. So I like these jobs. I saw a couple others just because I have kids your age and I always send them jobs and I feel like I'm bothering them. But I saw a neat one as a shoreline surveyor, which required GIS, out in, I think it was Onslow County, and then like park rangers and environmental scientists, since my daughter did graduate with a degree in environmental science and is not doing environmental science as we speak. So the other thing here, and when we start looking at announcement and course modules, what we're starting to look ahead to, we'll talk the exam later, but we've got these Esri tutorials. Has anyone been doing the Esri tutorials? I'm not looking for anyone raising their hand. But we've got these Esri tutorials. Just go follow the tutorials. Relatively easy to do. We've kind of posted a lot of those. They're focused on crime mapping, cell phone analysis, all that other good stuff here. You get a 10 out of 10 for doing those. So you do all 10, you get a 50 out of 50. The other thing down below here is we've got a story map. A story map is basically a big web page in which you can insert maps. And so on December the 2nd, we're going to have a story map tutorial that's going to be due. And you can see some of the things that students have done already. I really like these, but you can see some of the prior story maps that students created for this class. I swear they're here. Okay, this is one by Juan. He did this last last year about understanding sexual crimes as a danger to minors. And so he created some maps. He was focused on Durham County, but we're looking at all the schools and then all of the crimes within a certain distance of our schools, and then looking at relationships between some of this data that he got from the FBI. The one thing that I like about story maps, and so he did a little bit of research here. This thing's kind of slow right now, but he created this little swiper thing right here, which kind of moves back and forth between the crimes. Where are these sexual crimes for minors located in Durham County? And this is what we call a hotspot map. As you can imagine, a hotspot is just going to be an area where there's high activity. When we start talking about this in geostatistics, it's a little bit different when we start talking about things like statistical significance and all that other stuff. And so this hotspot map is really neat because instead of looking at all the dots on a map, it's basically grouped those as what we call like a density map. And we'll talk a little bit more about that in the next chapter. And then we'll be creating our own data in chapter number 6 or unit number 6. But you can see all these data here. You can see at what scale they're grouped at. So you can see very fine scale, very coarse scale. Sometimes I like making maps like these because the personal identifying information isn't there. They're like, isn't X marks the spot, X marks the spot, X marks the spot, where a lot of times you might want to hide some of the location data related to like forceful rape or crimes against children, things like that. And so when we create hotspot maps like this, I think it's a better way of representing it here. But I thought this was really good. We can look at pornography consumption by state, credits. I thought this was really neat. You can see spatial relationships with these here. This one looks to be a little bit more of a checkerboard pattern here, but I thought this was neat here. Now the one thing about these story maps here is that you can do a story map and then you can send it to your future employer when you go for an interview. So instead of me walking around with these big paper maps, which I literally have done, like I walk in with a couple of paper maps under my arm and say, look at all this cool stuff I've done. And I show them maps that are obsolete because the data are being updated on a regular basis. You can send them this and say, hey, this is some of the work that I've done. It's well researched. You can see we got some of the data sources down here, but you're going to be creating a story map just like this that'll live and breathe on our cloud-based services. Here's another one as well. Uh-oh, there seems to be an issue. I don't know who to blame on that one. So. And then the other one, examining motor vehicle thefts in incidents in Charlotte. This was a really good one as well. This uses something called a sidecar. And so it's basically kind of like two web pages working together, but you can kind of tell the story on the right. And then as you go down, it's got information about the crime and the statistics and all those other things there. But you can see the student went to the City of Charlotte Open Data Portal, and he just went and downloaded all the motor vehicle thefts here. He did some basic transformations, data portal. You can see right here, once again, look at all, this is what our raw data looks like. What's this look like to me? And probably looks like the same thing to you. It's just a bunch of dots. So how do we turn this into something that we can kind of make sense of? We can click to see the results. We kind of looked at Charlotte versus the rest of Mecklenburg County because we've got these issues of what we call logical consistency, meaning Charlotte Police Department might be different from Mecklenburg Sheriff's Office in the manner in which they collect data. So you can see right here, Travis addressed issues of logical consistency, looked at the motor vehicle thefts, and then once again, he created a nice little heat map, cluster map, hotspot map over here. You can see over here, there's a nice little hotspot over here at the airport, if you've ever been there. And then he did something called a spatial join, which we're going to talk about today. We'll start talking about that today, where that we can count the number within particular units. So as long as we have the location, we can count the number within them, because we can run an attribute query. I can say, how many occurred here? How many occurred here? How many occurred here? using an attribute query. But the one thing that we can do now is, if I were to ask you what block group or what county or whatever has the most, are you gonna go and like calculate it for every single one and give me an answer, give me an answer, give me an answer? Of course not. So we have something called a spatial join that allows us to do that. So instead of looking at a whole bunch of points, what we can do is look at a map that has, I guess these are block groups or maybe even census tracts that count the number within. Can you see a spatial pattern here with motor vehicle thefts in Charlotte? You bet you can. Over towards the airport, over to the east side, or west side right here. This southern part down here, definitely not. Over near Matthews, Pineville, but Myers Park was down there too as well. But we can look at the spatial patterns related to those. So this is a really neat project where he took data sitting in a portal that we geocoded or did add XY to, and then turned it into a map that looks like something like this. And so then what he did was normalize the data. And so now patterns basically didn't change too much, but now we looked at the number of motor vehicle thefts, not deaths, motor vehicle thefts per 1,000 people. So the patterns still look about the same, because typically when we make census tracts and block groups, we try to make these the same size in terms of population, even though there's a lot of variation in those from time to time. And then we've got a cluster map. We got hot spots and cold spots. A lot of times on a map, if you see anything that's red, what's that tell you? So, hot spot, something's going on there. Look at me, look at me, look at me. A lot of times web designers, when they put too much red and too much flashing on there, it gets overwhelming. And then when you're on a web page that you don't understand, what do you do to it? I click a little X on the top and just go somewhere else so I get a little less confused. Look for something so I get a little less confused. And so Dr. McGinn talked earlier about what are the colors, what is the layout, what are all the things, essential elements of map design to attract users. And those things are still alive and well, but you can see some hot spots and cold spots right here. This whole area to the south is what we call a cold spot. So it's a low area. Low means lower than average. We should know how to calculate the average. You know, we add them all up, divide by the total number here. But these are all kind of mathematically based calculations. And we can run into issues, and we'll talk about those in our geostats class a little more than we have here. But a lot of times your boss, they're going to want to look at hot spot and cold spot maps. They're going to want to look at maps like this. And hopefully by the end of this class, and I think we're getting to a point where we know how to make maps like this from some of the raw data. Right? And then we can start to see the trends in the trends here as they get to more and more here. But this was a really great example. I posted these in the announcements a few days ago, about 10 days ago. But these are going to be the expectations for the project. But this is a neat one here. You can see between 21 and 22. You know what's going on here. You know, over at the airport, still relatively high, but what do we have going on here? We have what we call an emerging hot spot right here. I'm not sure where this is. I'm not too familiar with Charlotte here. This might be over near UNC Charlotte. I'm not sure. Yeah, but this is swipe. This is what we call swipe technology. And so when you create a story map, you can add all these things onto there. Okay. And I did the swipe with the cemetery where I had the drone image and moving back and forth versus 3 feet under versus 5 feet under, what you can see, because these are all geo-referenced as well as these. These are all geo-referenced maps that are sitting in ArcGIS Online that you've all stored. Yeah, oh yeah, it's pretty neat. This has got the rubric here. We posted the rubric, but it's going to be due December the 2nd at 12 o'clock. If you got any great ideas, let us know. To me, what I would just want to do, anything related to anything you're interested in. So if you're interested in, traffic down in Charlotte, traffic thefts down in Charlotte, this has got the rubric. Make sure you have at least 5 pictures, explanation of your pictures. We have links to data from your map. You can see that some people created data from scratch, but if you want to utilize some of the project's some of the data that we've worked with already in class, you're more than free to. The other thing, spelling and grammar is really important. Okay, I kind of put that there. We had a former student and they applied for a job and the very first sentence misspelled the word there. They spelled T-H-E-I-R instead of T-H-E-R-E. And I look at that in the first sentence, me as an employer, what do you think I'm going to say? I'm just going to put it into the no-no list. Okay. And a lot of times, even with the AI and the ML, and we love these, I love them so much, but a lot of times those kind of errors are going to get through the cracks. Definitely get through the cracks. And so spelling and grammar is important. One thing I like to do is I like to just send it to someone else so another set of eyes can get on it. Aesthetics. Some of the things Dr. McGinn talked about. What colors do you have? Do we have black on white? That's what we call contrast. So I can notice the difference between the highest and the lowest. Or do I have different color grades, color ramps? If I go from light green to dark green, I know what one's the highest instead of having a pink, a green, a yellow, a blue. So I have to refer to a legend, which just gives me something extra to do. And then also project difficulty. Okay. Did you expand on the skills that we talked about in class? Are you utilizing some of the Esri tutorials that we're looking at, or did you just click publish map from one of our exercises and say, hey, I'm looking at the homicides that Mulrooney did back in 2022. And so we kind of put some things there from, are you using Story Maps data? Are you using something from the exercise? Or did you go out and create your own? Creating your own might be, hey, Mulrooney gave me all the 2022 data, but I'm going to go look at all the prostitution. I'm going to go look at all the motor vehicle thefts and then make my own conclusions from those data. And those would definitely qualify as creating your own data and being able to extract from existing data sources, because there's some value in that. It's going to be very rare, except in Unit 6, when we go out and actually create our own data. And we're going to talk about turning our phone into a GPS unit where we're going to do something called Survey 1, 2, 3. And we're going to actually go out and create our own data and then see how we can apply it to crime analysis, or at least get in the habit of, all right, I got to go ahead and create data. What are things that I want to know? The crime, the day of the week, or other things that are related to that. So today I'm going to talk about exercise unit number 4. Unit number 4, you can see what we've got here. We've got tables here. You can see over in the left, I've got some attribute tables as well. I've got some crimes here from 2020 versus 2021. This is taken from a student's master's project where he wanted to see if there's a difference in the tenor and dynamics of crime in COVID in 2019 versus right at the beginning of COVID. So we looked at the same period from March to June in 2019 versus all the crimes from March to June to 2020. Why did I have to keep the months the same? Kind of a silly question, but I just want to hear people say it out loud, and you folks joining us then can answer as well. Why did I say March to June? Why didn't I say March to June for one and then April to May for the other? How would I do that?
Because you want to have an apples to apples comparison.
Exactly, apple to apples. Even if it's like 3 months, you will start to see that the crimes are going to change. Well, I did 3-month periods in 2019 versus 2020. So we want to maintain all of the consistency with these as well. Now, when we look at this attribute table, you can see I've got a column here that says day of the week. MO, Monday, Wednesday, Monday, Monday. Okay, if I go down these here, how many different possibilities do I have for days of the week? We got 7. So we got a WE for a Wednesday, a TU for a Tuesday. Some of the things that I can do with table operations, and I think this is a real undervalued part of GIS, because if you ever worked in Excel, they have these things called pivot tables, and they get really difficult and ugly to deal with. I don't like dealing with pivot tables because all the things I can do in pivot tables, I can do right here in ArcGIS Pro, which I really like doing. They don't call them pivot tables, and they don't give me extra menus to use. I always thought it was kind of interesting about what day of the week had the most number of crimes. Like, what day of the week has the most number of crimes? Any guesses why? Weekend. Should be. Good. Let's see. So one of the things we can do here, I can write mouse click. Now, when I write mouse click, I can sort ascending, sort descending. When I write mouse click, this is what we call a context menu. I can look at the statistics, visualize the statistics. Now, there might not be a lot of statistics here because it's difficult to run statistics on Tuesday, Wednesday, Friday, Saturday, because they are what? They're nominal or categorical data, right? They're the name of something, the name of a day or category, because there's only one of 7 possible values. I can calculate the field, I can hide, I can sort ascending, descending, but we have something here, a real undervalued function called summarize. So I'm going to click on summarize, and summarize to me is kind of the nominal and categorical equivalent of statistics. You know, I want to average up, or I want to find the top 2013, I want to find the highest, I want to find the lowest, I want to put those into a histogram, but I also want to do some other things as well. And I can right mouse click right here. So now what do I have here? For 2019, I have FR 1472. What do you think that's what's the word frequency mean? How many there are? Exactly. So really quickly, I created a frequency table, and I can see that Tuesday, Monday, Friday, Wednesday, Thursday, Saturday, Sunday. Saturday, Sunday had the least number of crimes during this time period, which I thought was kind of neat. Yeah, I thought was kind of neat. Other things we can do, and one of the neat things that I thought was, what about the report date? Like, what day was it reported? What date do you think in 2020 during COVID would have the most number of crimes or the least number of crimes? And I can run a little summarize right here, and I'm going to talk about all these functions as well. But I always thought this was kind of neat. Okay, frequency. I can graph these, but 3/5/2020, 3/4/2020, 6/9/2020, 5/26/2020, 6/30/2020. Let's go, 3/2/2020. There's a relationship with these. You got some at the beginning of March, towards the end of June, end of May. Anyone know why? And I'll be honest, I don't know why either, But why would we have these? Here, these are probably, everything hadn't shut down quite yet, right? Because I remember I had I'm a leap year boy, so I had a real birthday that year, but I didn't go out because I had a staph infection. And then that week, everything kind of shut down. So maybe we're at pre-COVID levels of crime right here, but what about the 6/29, the 6/30? What are the chances that 6/29 and 6/30 happen to be 2 of the 121 highest crime days? Minimal. And in geostats class tonight, we're going to talk about inferential statistics. What are the chances that these two just happen to be right next to each other? I don't know. So maybe we could figure out why. Previous data that we were working with, like for 2020 or 2021, we can, one year it was like 2021 where we were looking at it, it was like January 7th and January 8th had like the least number of crimes by like half. And if you Google it, you look at the weather, it was a snowstorm that day, which I thought was kind of interesting. So how does snow impact crime? That might be a really good idea for, project. What days of the week had the most? What date had the most or the least? Maybe you can start to figure out the whys on some of these, which I'm really, really interested in, because Dr. McGinn, or especially myself, I'm kind of really interested in the where business, but the why business, I would really like kind of help with that or whatever.
Yeah, that's a Monday and Tuesday. That's weird.
Yep. Previous versions were like Wednesday, and Wednesday used to be like payday back in the day. So I remember people would get paid and things would go really crazy. So
I wonder if that was the first distribution of checks that the government sent post-COVID.
Yeah.
Yeah.
That might be the first distribution of COVID relief checks.
COVID relief checks.
Wow, I did not think of that.
That's why we team teach this, Tim.
Yes. All right, so when we were talking about the geographic data components, all the technical terms we have are layers, themes, feature classes. I sometimes throw in the word shapefiles here. They all represent the same thing. Over in your table of contents, that's the features on the left. So we might have a feature class for crimes, buildings, NCCU outline, and streets, all these other things that put together and make a nice pretty map. Individual instances of a crime are called records. So if I've got 10,000 crimes, I've got 10,000 records, and they're going to be described using attributes. What's the information about a crime that you're going to want to know? Day of the week, type of crime. Like I've said before, you're working for the city of Reedsville. They have a GIS person. They also have, they're also kind of bundled into like public affairs, but city of Durham, Winston-Salem Police Department, they have a GIS person that does crime analysis. What are the 3 words their boss does not want to hear? I don't know. Hey, can you give me the most frequent day of the week with crimes? I don't know. I didn't collect that. Okay. And so what are all the attributes that we want to collect about that? Okay. And those are really kind of difficult. Now, the other things that go on, all the datum and projections and all those other things that Dr. McGinn and I worried about when we got into GIS, this is 25 years ago, we kind of worried about, but now when we make maps, they seem to be just magically superimposed on top of each other. But there's a whole generation of people like me who that wasn't the case. And so when we look at a sex offender, this is one that lives over near me. What's the information about a sex offender that we want to know? All right, what's their release date? What was the offense date? What was the statute? What was the description? Are there any identifying marks? What's their birthday? He's about my age right there. What is their registration type? What's their minimum registration period? These are the attributes that are going to be collected that are going to be different than other types of attributes. This is crime, this is crime-related data as well. Where we may look at incident description here. And City of Greensboro has a crime mapper. So you can see 3X Village Lane. This is over where I used to live, over near Dolly Madison and Guilford College. But what's the information that's collected by it? Motor vehicle theft. What's the date? What's the time? What's the address? Or the accuracy, meaning, all right, we got it down to the address level, but we don't want to kind of highlight the poor person that got their car stolen, so we'll just put a couple of X rates there. So data comes in a lot of different forms. Last unit we looked at latitude and longitude, X and Y, addresses. Now addresses are a little bit trickier to do that using geocoding, but we're all able to collect these. Here's some data here. This is census data. If you go to the census data website, data.census.gov, you could go and download all data that looks like this, and then we would run something called a spatial join so we can match it to spatial data of zip codes. The zip codes 27358, 27406. Those are just identifying numbers. Just because my zip code's higher than your zip code, that doesn't mean anything. So it's just kind of like an 820 number for a zip code versus something like a census tract or a county or a state, which have their own independent and unique identifying numbers here. This is data as well. So these are high school graduation rates for 2007 versus 2012. They're identified by a particular county. Other types of data that we have here, crime data. This is the data sitting on the Open Durham portal here. You can see 220-0131. We have a larceny for shoplifting at 2700 Durham Chapel Hill Boulevard. Can we put that on a map? You bet we can. Of course we can. I do it with my phone every day, but we talked about the process of geocoding. Geocoding, if you're going to get into crime mapping, geocoding, adding XY data are the skills that you're going to need. Because your police chief, your boss, your city administrator, they could probably barely spell the words GIS. But they're gonna wanna know how we can just make pretty maps. And you're gonna be the ones turning stuff like this into maps that have the vehicle theft, the days of the week, all those other things that turn this information or this data into information and eventually turn it into what? Action. That's what we want to do. You know, we don't have, Reedsville isn't investing in Reedsville is a relatively small town up near Maine. They're not investing in a crime analyst just for the sake of investing in a crime analyst. They really want to facilitate, they want to look at results. You know, and how do we measure those results and assess and evaluate these results here? Okay. And with computers, we've got lots of neat things. You know, I scroll through on my little Instagram, it knows how long I stayed on that little thing about, you know, wrestling versus the football versus everything else. It knows how long I stayed on that because guess what's going to show up next time? The thing that it knowed I stayed on. So really interesting things there with data and all the ways that we can encapsulate data. Now, the power and effectiveness of GIS, and to me, over Excel and Access, is that we can sort highest to lowest, ascending, descending, query. What's this word query mean again? Asking questions of the data. How many crimes occurred within a certain distance of a school? How many crimes occurred on a Wednesday? How many crimes occurred on a Tuesday? And just what we talked about now was the idea of summarizing data. I can't average up Monday, Tuesday, Wednesday, Monday, Tuesday, but I can count how many times each of those days of the week occur. I can count how many times each of those dates occurred, where I can say March 4th, March 5th, then what? June 29th, June 28th, June 30th. Man, we can look for relationships, not only spatial relationships, but temporal relationships related to those. And other things we can do is calculate numerical data. So I can find, let me look at the motor vehicle thefts by zip code for all of Charlotte. Which one has the most? Which one has the least? It has a min, it has a max, it has a range, it has an average, or a mean and a median. So there's a lot of different things that we can run here. And so, like we highlighted here, I can right mouse click on a particular column right here. And these columns are what we call fields. And we have a field here called median age, MED_age. And I can run statistics on those. I can also run summarize, but when I run summarize on numerical data, it's, I don't know, we don't want to deal with that, but I can make something like this. Now, does anyone know what type of graph this is called? Don't answer, David, because you are taking this class already. But what type of graph is this called? Anyone remember, Fred? Bar graph or histogram? You got a histogram right here. And so this is a frequency distribution here. Okay, so basically this bar shows how high it goes to frequency, and then on the x-axis is the actual value. So from 25.9 to 28, we only have one county that has a median age. Over here we have lots of counties that are between 40 and 42. This is what we call a normal distribution. And yeah, I like talking about football and baseball, but if we were talking about the number of teams, football wins, we'd have very few teams like the Jets with 0, very few teams with like 7 or 8 wins. Most of them are going to be like 3, 4, 5. The Panthers are right there. So right in the middle right there. Yeah, not too many with 5 or 6. So this is what we call normalized data, normalized distribution. A lot of times when we look at frequency, it's going to be a little bit different, especially when we look at like populations or counts as opposed to normalized populations. So if you look at that if you go back and look at that Charlotte motor vehicle theft map, he's got the raw numbers and he's got the normalized numbers that look at the number per thousand. Over on the left here, I've got the mean, the median, the standard deviation. The standard deviation just tells us how far these data deviate from the mean. For our midterm, I kind of put a couple of hypothetical football teams that won 4 games one year, 10 games another year, 2 games one year, 11 games another, and then compared it to another team that won 8, 9, 8, 7, 8. They had the same mean, but different standard deviation. So we start to get into the dynamics of the actual individual data, but these things are what we call descriptive statistics. They describe the entire data set. And those are good and well for a lot of things here. Hey, my team has won an average of 10 wins per season over the last 5 years, while your team has only won 7 games per season over the last 5 years. And those tell powerful stories. Those are what we call descriptive. They describe the entire data set, but it doesn't tell us about this individual instance, which we call local data, as opposed to this stuff is called global data or global statistics here. Now, general statistics also we have here are, hey, let's look at the number of crimes, or we can look at Friday, Wednesday, Tuesday, Thursday, Monday, Saturday, Sunday. We can export these, put these into Excel, because Excel, for the most part, does have good ways of manipulating data, creating charts and graphs and all those other things that I think ArcGIS Pro, especially with the nominal statistics, doesn't do as well. But what we work with here is what we call non-spatial data. And I'm really trying to kind of formalize this term called spatializing data. Space geopotential, geospatial potential, meaning we've got this data sitting in a cool table. I want to turn it into spatial data. Most of the data you see around here is just something that was extracted from a table. There's not a map out there of ulcerative colitis in North Carolina. There's not a map out there of SIDS deaths in North Carolina. We had a former social work student who mapped SIDS deaths because they were impacted by SIDS deaths. What we did was we got a list of all the deaths. We looked for something called an ICD code, International Classification of Death code for SIDS. And then we just said, hey, let's look for all the SIDS deaths within this big database. And then we mapped them using something called a summarize. Hey, which zip code had the most? Which zip code had the least? And so we could run something called a spatial join, which we'll talk about later, or a tabular join as well. Back behind Trey in the corner there, we have something on birth defects. Birth defects are really, really high in the southeastern part of the state here. That purple map back there. Okay, really high in the southeastern part of the state. I like that map there. You can see how faded it is, but I kept it here because a couple social work students found a big Excel spreadsheet of birth defects, and then we did something called the spatial join or tabular join, just to join it to the attribute data, because we have an attribute table that has county name and value. We have a standalone table that has county name and value. We can just link those together so we can map those. Now we can see it's really high in the southeastern part of the state, but I don't know why. Why would birth defects be high down there? Probably lack of prenatal care, more teen mothers.
Pollution.
What's that?
I said hog farm pollution.
Hog farm pollution. Yes, that's gonna be my next millionaire, idea.
That's right.
There's lots of places here. Department for Health Statistics, Department of Public Safety. We can click on this button right here, and we can look at all the people that were admitted to prison over the last year by county. Can you make a map out of that? You bet you can. Okay. We have the North Carolina Department for Health Statistics. I can click on this thing right here. And we've got Department for Health Statistics. I'm going to move it over to here. So we can look at BRFSS, Behavioral Risk Factor Surveillance System, questionnaires, survey results. Tons and tons of data out here on potential data here. Survey results, health status. How many healthy days have you had? Healthcare access. North Carolina Vital Statistics Database and Department of Health Statistics has, what do they call it? Children under the age of 1 who die. I forget what the name of that's called again. But lots of neat data out there that can be mapped.
Infant birth rate, death rate.
Yes, that's it. Infant birth. I should have
Death rates, yes.
Yeah, birth rates and death rates. So we can look at, and this is what some of the raw data looks like here, where we have age-adjusted death rates for cancer mortality for colon, rectum, lung, breast, prostate, cervix, melanoma skin, all types of cancers right here. Now, those of you who kind of get into health mapping, or those of you who get into crime mapping, got a lot of things going on up there. We have per 100,000 population, meaning that, well, what counties would you expect to have the most number of deaths? Wake County, Charlotte, Mecklenburg County. Why? Because they're so large. So we normalize these by rates. The other thing we have here is the word age adjusted. And it's kind of a silly question here, but what ages of people do you expect to die at higher rates than other people? What ages of people do you expect to die?
Older people.
Yes, exactly, older people. So when we map death rates, basically, what are you mapping? Where all the old people live, So we can do something called age adjusting, which normalizes for age, which I think is kind of interesting too. So zoomed in, we can extract these PDF files into Excel and do a little work here. Your biggest work in a lot of these things here, a lot of this work is turn this data into something that's bring into our ArcGIS Pro. Now, what are the different types of data that we have out there? You can click on like the North Carolina or Guilford County parcel mapper, because we have a lot of different types. If you click on my little field right here, we got an owner. And Dr. Wiggett, this is where my wife wants to build here. So this is my new effort for the next 6 months until she gets something else in mind. But that's another story. But you can see the owner, the assessed value, the number of bedrooms, the deed, date, and the acres. Now, bedrooms. Can you have like 3.5 bedrooms in a house? No. So you can have 1, 2, 3, 4, 5, whatever. So this is what we call an integer. Acres is going to have a little decimal point. People don't really care about the difference between these, but guess what? The computer cares. And these are what we call long and short numbers versus floating points or doubles. So when we start adding new fields, creating new fields, because all the fields we have there might not be there. The one thing you guys didn't notice about that crime data, and if you've been to the Durham Open Portal, if some of those data don't have day of the week, I don't know if anyone noticed that. It doesn't have day of the week, but I did a little Excel calculation that puts in the day of the week for me, based on that. So we have text, like my name, date, 9/25/2019, a short integer, a long integer. And then we have blob, which we call a binary large object, and then a floating point number. So a lot of times when we calculate new fields, because a lot of times people say, hey, this guy Travis who made our crime maps, there isn't just some magical field out there that says crime rate ready to go. If you know the population, if you know the number of crimes that occurred there, which we can extract from GIS, can you calculate the crime rate? You bet you can. So we can calculate brand new fields that we can display. Now, has anyone ever done this in Excel before? Of course, I can calculate this in Excel. Okay, I can calculate the percentage of people over the age of 65. I believe it's something called the elderly dependency ratio or something like that. But we can get this through the census. These are going to be attached to most of the data that we give you at the census tract level. So we can compute these as well. And we can do this in Excel by just putting that little equal to sign. And if you've taken my geostats class, you put an equal to sign in a column, you can start making formulas. You can get good formulas, bad formulas, junk formulas, whatever you want. So we can do the same thing in ArcGIS Pro. Now, when we click on those fields button, because remember, we've already clicked on sort ascending, sort descending, summarize statistics. I can click on fields, and then all the fields are going to pop up. So I can click on a short, a long, float, double, date, text, blob, grid, raster. I don't deal with too much with these down here. But a long and a short are going to be decimals. Long and short are going to be what we call integers. Do we store your GPA as an integer? What if you got a 3.48? What's that going to make it? You can make it a 3. You want to convert your 3.48 down to a 3? No. So we're going to save it as a float or a double. Okay. And it's really minute, but when we start getting rid of decimal points, it takes up all the ones and zeros and all the space to store numbers as opposed to decimal points. You get really ugly really quickly when we start to store in decimal points. Now, no one cares about that because we lose 8 gig, flash drives in our dryer. They sit there in my car. They sit there in my glove box these days. But my first desktop computer was like 8 gigs of memory. So we cared about memory back then. You care about memory when you try to get that picture and all of a sudden it says, you've run out of space. You better do something now.
Wow.
Your kid's first steps or whatever. You've run out of space or something funny. Your friends are doing something funny. So we're going to stop here and then we'll continue on the next day I see you, which is Wednesday. Okay. So everyone have a good day. We'll see you all later.
All right, thank you.
All right. See you, David.